Hello, this is the method of undetermined coefficients, which is called annihilators. It's a very interesting topic to solve non-homogeneous differential equations. So let's get started. As you can see, I'm highlighting the main word annihilators. According to theorem 8.1.8, the general solution to the non-homogeneous differential equation P of d y equals f of x is of the form y of x equals yc plus yp. Remember, yc came from the homogeneous differential equation, and this is called the particular that handles f of x. Earlier we showed you some examples, but we did not show you how to get yp. In this section, that's one of the main focuses, especially on some special functions. So this is not going to solve the whole problem 8.3, so we have coming sections that they're going to show you how, if those functions on the right side are different than the listed in this section. So let's move on. Where yc is the general solution to the associated homogeneous differential equation and yp is one particular solution to the non-homogeneous. We have seen in the previous section how yc can be obtained. We now turn our attention to determining a particular solution called y sub p. In this section, we develop a method that can be applied whenever f of x has a certain special forms. One more time, this section is mainly made for special forms of f of x on the right side. This technique can be introduced as follows. We have p of d. That's, if you remember, the way we write the differentials on the left side, and then we move it to write the auxiliary function. That's PD, differential operator, applied to y equals capital F of x. Suppose there is a polynomial differential operator a of d such that when you apply a of d to this capital F, will vanish it, will cancel it, and that's the word annihilator, kind of like destroy it. Okay, so if you could find a of d that will handle f and will move it out of your way, this technique is kind of like smart by showing or changing the non-homogeneous differential equation to a homogeneous, and you know how to find the homogeneous one from previous sections. So here we go. We have seen in the previous section the following right here, and now we're moving to something else. Then operating on the non-homogeneous differential equation with a of d on both sides will give you the homogeneous differential equation. As you could see, p of d times y equals capital F of x, apply a of d, which you don't know now where it's coming from or how, to both sides. On the right side, that's a 0. Notice that I'm writing it clearly here because that's the main focus. We need this to change. So we are transforming the differential equation here, which is non-homogeneous, to a newer one, but it's a homogeneous differential equation. Homogeneous differential equation. Here's an example. Determine the general solution to the following. P of d is d minus 3 times d minus 3, d plus 3. I think I said minus. D plus 3 times d minus 3 times y equals 10 e to the power 2x. That's P of d, which we could write as P of r as auxiliary function. We first obtain a complementary function called yc. kind of like ignoring this for just a few minutes and working with this only as homogeneous. Let's find YC. We know how, but let's do it. The auxiliary polynomial is P of R equals R plus 3 times R minus 3, which gives you the general solution for the homogeneous YC equals C1 e to the power negative 3x, because that gives you negative 3, and that gives you positive 3. That's a positive 3 right there. Plus C2 e to the power 3x. Okay, then what? Now, d plus 3 times d minus 3 times y equals 10 to the power e to the 2x is in short written also this way, where capital F of x is 10 times e to the power 2x. We need a polynomial differential operator AD such that AD times this capital F will force it to be 0. It is easily verified that now you don't know where d minus 2 is coming from. Just this is an introduction example. Usually, as you know, examples are kind of like ideas to help you understand the text with some numbers, and they call them examples. So let's do this. We have d minus 2 times e to the power 2x, or this differential operator applied to e to the 2x. We want to see if this gives you 0. We know how to do it, but I want to skip the steps. I'll show you the steps to save some time. Here we go. You just apply it step by step and you end up with the right hand side, which is 0. Now, applying d plus 2 to our function that has 10 in front. This does not have a 10. We'll do the same thing. 10 is not going to do much. I have 20 e to the 2x minus 20 e to the 2x, which is 0. So for our function, d plus 2 will destroy it, and that's the word annihilator. So d plus 2 will do the job. Okay? Now, so far f of x equals 10 times e to the power 2x. We can use AD equals d minus 2, since AD times f of x, or differently d minus 2 times 10 e to the 2x equals 0. Okay, sounds good. Let's do that. D plus 3, d minus 3, y, that's p of d. That's our main non-homogeneous differential equation, written back again. Operating on this differential equation with AD, which we agreed on as d minus 2, will give us the homogeneous differential equation. Okay, let's do that. Here is d minus 2, here is d minus 2 to both sides. Right side we know already, that's gonna be 0. And here we go. Now, if you don't see this in color as green and red, and you want to solve the YC for this problem, you know, you have like R equals 2, R equals negative 3, and R equals 3. But that came from this technique, so it's not R. Okay, just gotta be careful. We have to treat it differently. We have a new homogeneous differential equation that we created, which has the general solution. So those are for R, as you could see. In red, that's for these two guys. Alright? For this one that we came up with, we're going to write a sub 0. It's not a C3. It's a particular solution to the non-homogeneous. So because if this is 17, that cannot be anything, just like, you know, randomly C3. It has to be some number that will force this to be true and ends up on the right side with 10. So keep this in mind. This right here is clearly stated. This shows up from this number 2 up there. This is not C3, it's a sub 0. This solution must contain a particular solution to the non-homogeneous for appropriate values of the constants C1, C2, and a sub 0. However, the first two terms match with the complementary function to the non-homogeneous and therefore satisfy the following. You could test it. You could make this t squared minus 9, multiply by this step by step, apply it, and you'll see it's going to work. Alright? Thus, the non-homogeneous differential equation must have a solution of the form. Because it's non-homogeneous, we need a particular solution, not to give you 0, give you something else. We call yp a trial solution. It contains one undetermined coefficient a sub 0. How do you find a sub 0? This is first time, so just be patient. It's not really complicated. It's just like first time. Everything first time looks a little bit off. Slow down, you could pause and just watch the steps. How do you find a sub 0? In order to determine the appropriate value of a sub 0, we substitute the trial solution into the non-homogeneous differential equation. Marked with the 2 stars, that's the original non-homogeneous differential equation. And that's it. This is a 1. So let's do that. You see the word substitute, so it's not really complicated. Instead of y, we're going to write yp. Instead of f of x, we're going to write what we know. And we're going to do the algebra steps and finish it. So, here's yp is the assumed a sub 0 e to the power 2x. And d plus 3, d minus 3, I wrote it as d squared minus 9, just for the convenience. Instead of doing this, then when we finish, do this again for the other parentheses. I have one set of parentheses right here. Okay, what's next? We take our time, apply this and apply this. Second derivative of yp minus 9 times yp. Second derivative of this, 2 is going to go up front first time and second time is going to give me 4. Notice the terms are identical, so it's 4 minus 9. I have minus 5. Comparing these two values to the right and left, I think it's so obvious that a has to be, a sub 0 I mean, has to be negative 2. We are almost done, so here's yp. Minus 2, not any random number like C3 or a sub 0. A sub 0 means it's fixed, but we found it now, so we take it back. The general solution to the non-homogeneous differential equation is 2 parts yc and yp, and that should do it. Here we go. This is from the complementary original without any work, ignoring capital F of x, and this is the new technique that we did today. Just giving you something that you did not know earlier, which is d minus 2 that showed up. Okay? Here's an example. This is just to practice. As you can see, examples are just like to give you ideas with numbers instead of just reading text. Show that this AD analyzes 5 cosine 2x. So if you apply this to this capital F on the right side, it forces it to be 0. That's what they're saying. Solution. Let's apply it. AD multiplied by capital F of x. D squared plus 4 times 5 cosine 2x. We could take the second derivative, then multiply by 4, and simplify. Second derivative, multiply by 4. Take your time and find the second derivative. It's right there. Oh, look, it is opposites. So it does cancel, and yes, this is the annihilator for 5 cosine 2x. Now, it's kind of hard to write the whole book and show you all the formal techniques, but to help you understand it, I built this columns, let's say, if you want to call it, to help you step by step understand the most common ones. If capital F of x of this format, e to the ax, or x e to the ax, or x to the power k e to the ax, AD that will annihilate any of these formats is of this type, d minus a to the power k plus 1. Alright, let's take some examples. How about 16 e to the 3x? Notice here there is no number up front, so it didn't show up. This a right here showed up from the exponent, and if you have an exponent right here, it showed up from the exponent of x. Kind of hard to say it, but if you compare back and forth, hopefully we'll do it. So let's just, before we see the answer, quickly compare some ideas. First of all, a up here is 3 in my example, so that should be 3. There is no x, in other words it's x to the power 0. That's going to be 0 plus 1, which is just 1. So I'm assuming d minus 3 to the power 0 plus 1, or just 1. Yes, d minus 3 to the power 1. Let's try some more. 15 e to the power 4x. What do you think? It's so similar. Here we go. D minus 4. How about 7 e to the power 2x? I think you guessed it. D minus 2. You could test it if you want, but that's the format and we are following it. We did one example, so that's where it comes from. This time we have a little bit different example. It has an x in it. See the x right here? That's the x. So here's a, and k is 1, x to the power 1. So I believe inside parenthesis is going to be d minus negative 2 to the power k plus 1. K is 1. So here we go. D minus negative 2 is plus 2. K plus 1, which is 1 plus 1, and that's 2. K is 1. 8 e to the power negative 3x. It's going to be d minus negative 3, which is d plus 3. Alright. One more. 8x to the power 5 e to the power negative 3x. This is my a, this is my k. Give it a try. Okay, I think we're clear now. Here we go. D minus negative 3, which is d plus 3, to the power 5 plus 1, which is 6. That's for the e part and x involved in it. Here's cosine and sine examples. If you have 5 cosine 2x, d squared plus 4. We saw that earlier. In general, cosine bx will give you d squared plus b squared. D squared plus b squared. B is 2, so that's the 4 came from 2 squared. How about sine bx? Same idea. D squared plus b squared. How about 10 sine x? See, the 5 here did not do any effect, so I don't think the 10 is going to do any effect. So here we go. D squared plus 1 squared, which is 1. In case if you have a polynomial like this, the answer AD that will destroy it is d to the power k plus 1. I don't want to talk too much about this one, it's just common sense. Imagine if this is a polynomial of 7th degree. I think when you find derivative 8 times, we'll cancel the whole thing. Makes sense, right? because it's gonna keep it down step by step till you eventually you get a 0. How about minus 3x? You need one more right here. One derivative is not gonna kill it. Two derivatives will kill it. D squared. As you can see, that's why I'm not writing a whole list of examples for this. Okay, let's try some more examples. 2e to the x. What do you think? D minus a. A is 1. D minus 1. How about negative 3x? Okay. D squared. We saw that. How about 2e to the x minus 3x? A combination of these two. Well, you need one to kill this, and you need one to kill this, or destroy it, or annihilate, whatever you want to call it. And now you need to have both multiplied. So it's not like you take them as separate problems and you just add them. You don't add them, you multiply them. So d squared and d minus 1 multiplied. You can test it and you'll see that's gonna work. Okay, let's try some more. 5 sine 4x. D squared plus 16, which is 4 squared. X to the third, e to the 7x. Remember that earlier? D minus 7, d minus a to the power 3 plus 1, k plus 1. Okay, two functions, kind of like f of x is combined of two functions. We're going to treat this, and combine them. They're right here. So what do you think the answer is? Yes, you multiply these two. This will cancel that, and this will cancel that, so you need to multiply them to cancel both. Okay, let's try some more. Sine x. D squared plus 1, okay, which is d squared plus 1 squared. 3x to the power 2x. D minus 2 to the power k plus 1, which is 1 plus 1. Sine x and 3x e to the 2x. I think you guessed it. You just multiply them, and that should be enough for this section. As I said earlier, it's kind of hard to write the formal ideas, so I went and replaced that with some examples as charts or tables in this way. Hopefully it was helpful. The main keyword is annihilators. How do you get that for special type of capital F of x? Once you handle it, you will become with a new homogeneous differential equation, and you treat yp the way I showed you, and that should do it. Thank you for watching. I hope that it was helpful. Hit the like button as usual. If you like it, subscribe, comment below, and if you like this video, hit the bell icon to be notified when I upload new ones. Until next time, peace, JaberTime. There's more videos coming. I prepared like 4 or 5 sections, so I'm gonna be recording tonight and uploading more videos by tonight. Thank you for watching.